Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following quadratic number patterns. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. A quadratic number pattern is that which the second difference between consecutive terms is constant. So in this example, we have considered the quadratic number pattern 1, 7, x and 31. Determine the value of x and hence the nth term of the sequence. So I'm going to start by listing out the numbers. We have 1, 7, x and 31. As stated earlier, the second difference of a quadratic number pattern is constant. So I'm going to start by finding the first difference. To find the difference between consecutive terms, we have the term in front minus the term behind. So it's going to be the first one, 7 minus 1, that will give us 6. And then we have x, which is in front, minus 7. And then I have 31 minus 7, or minus x, because x is the number before. So that will give us the expression 31 minus x. I'll tag this my first difference. So now I'm going to move to my second difference. So I have my arrows as shown. So going through the process again is the term in front minus the term behind. So because it's an expression, I'm going to be using my bracket. The term in front, x minus 7 minus 6. If I simplify further, that will be x minus 7 minus 6. I have x minus 13. The second one, I have 31 minus x minus x minus 7. If I simplify further, that will be 31 minus x plus 7. What I've done is the minus in front of the bracket multiplies all the terms within the bracket as shown. So therefore, if I simplify further, I have that as 31 plus 7, that's 38 minus 2x. And that will be my second difference. So as stated earlier, because the second difference is the same, all I need to do is to equate x minus 13 and 38 minus 2x. Those are my second difference. So that will give us x minus 13 must be equal to 38 minus 2x. Collecting like terms, I have x plus 2x equals 38 plus 13. What I've done is to move my negative 2x to the left hand side, and then I've moved my negative 13 to my right hand side. Simplifying further, I have that as 3x, that's x plus 2x, equals 38 plus 13, 51. And in order to find x, I'm going to divide both sides by 3. I have 3 and 31. Therefore, the value of x equals 51 divided by 3, which is 17. So therefore, the missing term x is 17. Now we can go to the second part of the question. It says, determine the value of x and hence the nth term of the sequence. So I've written my sequence again, and then I start again by finding the proper values of the first difference. That's the term in front minus the term behind. 7 minus 1, that's 6. Then I have 17 minus 7, 10. 31 minus 17, that's 14. So that's my first difference. I'm going to find my second difference as shown, and that's going to be 10 minus 6, 4. 14 minus 10, that's 4. And you can see that, as stated earlier, the second difference is the same. So therefore, starting with the nth term, we know that the standard equation for a quadratic pattern, we have a Tn equals an squared plus bn plus c. So we are going to find our A, our B, and our C. So starting with the first one, I start with the A. Note that the second difference, we use that in finding A. What we have is that's going to be A equals half of that. So that's going to be A equals half of 4. And then we're going to use the first difference as shown. That's going to be 3A plus B. And then the value of the first term at T1 is A plus B plus C. So working out what I've written so far, I start with the value of A. A equals to half of the second difference, which is 4. So that's going to be half of 4. Therefore, the value of A is 2. I go to the B. So those are the formulas I'm going to use for each stage. Going to B, I have 3A plus B will give us the first value for our first difference, and that is 6. I have 3A, A is 2, so I'm going to replace my A with 2 plus B equals 6. So I have 6 plus B equals 6. So therefore my B equals 6 minus 6, which is 0. Then in order to find my C, I have A plus B plus C equals to the first term, which is 1. We have the value of A, that's 2, plus the value of B, 0, plus C equals to 1. So I have 2 plus C equals to 1. Therefore, the value of C is 1 minus 2. I'm moving 2 to my right-hand side. Therefore, C is negative 1. So therefore, our nth term for this sequence will be Tn equals A is 2. So I replace that by 2n squared. I have B to be 0. So that's going to give me 0. Then I have C, negative 1. So 2n squared minus 1. So that will be the equation for the nth term of the series. Let's look at the second example. For the second example, I'm going to start by listing out a sequence, a quadratic pattern that's negative 4. I have x, I have negative 28, and negative 46. The first step is to find a first difference as shown, like I mentioned earlier. To find the first difference is the term in front minus the term behind. So that's going to give me x minus, and because that is negative 4, I'm going to put that in a bracket. So I have that as x plus 4. The second one, I have negative 28 minus x, and the third term, that's going to be negative 46 minus the term behind, that's negative 28. I'm using my bracket so that the signs multiply each other. So I have negative 46 plus 28, and that will give me negative 18. So that is my first difference. I'm going to go ahead and find the value for my second difference as shown. So using the same concept, it's the term in front minus the term behind. So the term in the front here will be mine negative 28 minus x minus, I'm going to put that in a bracket because it's an expression, x plus 4. And then for the second difference, I start with negative 18 minus, I'm going to put that in a bracket again, that's negative 28 minus x. So note that the terms I'm using are x plus 4 minus 28 minus x and 18. If I simplify further for each one, I have negative 28 minus x, then the negative in front of the bracket multiplies all the terms in the bracket. So I have negative 6, negative 4. And if I simplify further, that's negative 32 minus 2x. For the other side, I have negative 18. The negative, as I did earlier, multiplies all the terms within the bracket. So I have negative 18 plus 28 plus x. And that will give me 10 plus x. Note that this will be my second difference. And because it's the quadratic pattern, the second difference are the same. So therefore, I just need to equate these two terms. I'm going to circle that. The first term and the second term, which is negative 32 minus 2x must be equal to 10 plus x. So I collect like terms. I'm going to move my negative 2x to the right hand side, and I move my 10 to the left hand side. So what I'm going to have is minus 32 minus 10 equals x plus 2x. I have negative 42 equals 3x. And to find x, I'm going to divide both sides by 3. So I have 3 and 3, 1. Therefore, the value of x will be negative 42 divided by 3. And that will give us negative 14. So we've been able to find the value of x. Now we go to the next statement. It says, hence, find the nth term of the sequence. To find the nth term, I have my x to be negative 14. So I list out my terms again in the sequence. That's negative 4, negative 14, negative 28, and negative 46. I start by finding my first difference as shown, and that's the term in front minus the term behind. So that will be minus 14 minus 4. If I simplify further, that's minus 14 plus 4, and that will give us negative 10. The second one, I have minus 28 minus negative 14. That's negative 28 plus 14, and then that will give us negative 14. For the last term, I have negative 46 minus the term behind, negative 28. That's negative 46 plus 28, and then my term will be negative 18. So that is my first difference. For my second difference, I'm going to draw my arrow again as shown. So that's using the term in front minus the term behind again. I have negative 14 minus negative 10. I have negative 14 plus 10, and then that will give me negative 4. I do the same thing on my right, negative 18 minus negative 14. That's negative 18 plus 14. Therefore, my second difference is negative 4. And as stated earlier, because it's a quadratic pattern, the second difference will be the same, which is negative 4. So, using the standard equation of a quadratic pattern, that's Tn equals an squared plus bn plus c. I need to find my a, my b, and my c. Now, note that to find a is half of the second difference. Then to find b, I know that the first difference, that will give us 3a plus b. And then the first term of the sequence, we got that by adding a plus b plus c. So starting with the first difference, I have that is equal to, I'm going to write my 2a here. So therefore, to find a, I have 2a is equal to negative 4. So dividing both sides by 2, I have a is half of negative 4, which is equal to negative 2. The next step is to find b. And to find b, I have that as 3a plus b is equal to t2 minus t1, which is the first difference, negative 10. I know the value of a to be negative 2, so I'm going to put that in. Plus b equals negative 10. I have negative 6 plus b equals negative 10. I'm taking my negative 6 to the right hand side. I have b equals negative 10 plus 6. Therefore, the value of b equals negative 4. Last step is to find c. To find c, we have a plus b plus c is equal to the first term, which is negative 4. A is negative 2. I'm going to replace my values. Then I have b, negative 4. Then plus c equals negative 4. Negative 6 plus c equals negative 4. So therefore, to find c is going to be equal to negative 4 plus 6. Therefore, c equals to positive 2. Therefore, slotting in the value of ABC into the standard quadratic equation for the nth term, I have therefore my Tn will be equal to an squared, that's negative 2n squared, plus bn, so b is negative 4, so minus 4n, and then c plus 2. I'm going to change my c to 2. Thanks for watching. Bye.